NASA's Kennedy Space Center in Florida. I'm Megan Cruz, and this is Kevin Fryer with the National Oceanic and Atmospheric Administration, or NOAA. How are you?
I'm well, and thanks for having me.
You got some dinner while we were on this break?
I was able to just scarf down a little bit of food.
Good,
yes.
good. I started to get some dinner, too, and then I was like, oh, wait, I got to get back. It went by so fast, you know?
It did.
Well, we are back to continue NASA's coverage of NOAA's GOES-T, which launched about 3.5 hours ago above a ULA Atlas V rocket from Cape Canaveral Space Force Station behind us. If you missed it, here's a quick replay.
The final seconds now. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff. Liftoff of NOAA's GOES-T, our newest weather sentinel in the sky to help keep us safe here on the ground.
Daryl, let's listen in as we listen to United Launch Alliance Rob.
Just look good.
Who's the flight mission commentator?
View has gone to closed loop control. The RD-180 is now throttling down as expected. Engine response looks good. We are now 33 seconds into flight. Atlas is 3 miles in altitude, 0.9 miles downrange distance.
Max Q.
After launch, we followed the mission for 2 burns, and then we entered a 3-hour coast phase. That's why I was asking if Kevin got to get some dinner. We're still in that coast phase, but in a few minutes, we'll follow along for a unique 3rd burn and spacecraft separation. GOES-T is a weather and environmental observing satellite that's the size of a small school bus and weighs over 6,000 pounds. It has a solar array of 5 panels that you see there. It's that long arm swinging around, which produces about 5,000 watts of energy, which is the same power needed to run your home's central AC system. GOES-T has 6 advanced instruments that can analyze weather hazards and environmental conditions. For example, one of those instruments can take a new image of Earth every 2 milliseconds. That's 20 times faster than the regular camera. Kevin, NASA and NOAA have been launching GOES satellites for nearly 50 years. Tell us how the public benefits from this system.
Well, the public directly benefits from that particular relationship where when we launch these satellites, our goal is to make sure that we're monitoring the severe weather that's impacting us every single day. And thankfully, being able to do that, we've been able to say that we can save lives. Yeah,
you told me that GOES satellites often detect the start of a wildfire before people on the ground too. That is very impressive.
Yeah, it is amazing. It's a feature that came about with that particular system in which we're able to detect wildfires in the remote parts of the United States.
Now, there are 2 operational GOES satellites over the Western Hemisphere at any given time, right? That's how the system works?
Absolutely. So the system is really designed so that we can actually be able to track 4 separate storms or 4 separate events, whether they be out over the Atlantic or out over the Pacific or even across the continental United States.
Mm-hmm. So right now we have a GOES East and a GOES West. What happens when GOES-T reaches geostationary orbit? Does it replace one of those satellites?
It will. It will replace the Western satellite. The idea with this particular launch is that it will replace West. West will move into a storage orbit. So that way it's kind of what we call a hot spare, where we have the ability to move that particular satellite if there's any failures or any issues with any of the other satellites.
Talk to us more specifically about the different things that GOES-T can monitor. You know, we've talked about fog, we've talked about atmospheric rivers. Can you go a little bit in depth on those?
Sure, absolutely. So the phenomena that it's able to monitor are vast, as we already outlined, specifically with atmospheric rivers, which are typically mentioned nowadays, especially when it comes to flooding. So the concern for anyone that hears atmospheric rivers or the chance for flooding, well, thankfully GOES can provide us with some high-fidelity information to measure that actual moisture, to actually get a sense of when that flooding can occur, and more importantly, give a sense to the public the magnitude of that particular event.
And can send back pictures every 30 seconds.
Every 30 seconds, which again is tremendously. 10 years ago, we were sending images back every 15 or 30 minutes. The 15 was a special request, but every 30 minutes you can get imagery. So again, for back then, that's what we expected. That's what we could do. But technology has leaped so much further forward now. With this capability, it's also added greater capability to our forecasters.
Well, and in severe weather, seconds matter, right? So the fact that this is near real-time imaging is really spectacular. All right, we're now at the moment we've been waiting for. Let's bring in NASA commentators Daryl Nail and Mick Woltman to walk us through the mission's last burn and spacecraft separation.
Thank you, Megan. You've been talking about the science, the great science that GOES-T will do, and the meteorological observations, but we got to get it into its right orbit before it can do any of that. And as you mentioned, we're getting ready for the third and final burn here in just about a minute or so. Mick Woltman joining us, Launch Services Program Engineer. You're looking at live telemetry that is fed into an animation, and there is the Centaur upper stage.
Start on the RL-10.
Attached to GOES-T. You just heard the call out where they're shooting out the fuel.
Yeah, so we get the fuel in the right projection area.
About 45 seconds until MES 3.
So we get the fuel put in there, and they've pre-started the engine to get it ready to go for this MES 3 ignition.
And this will be a 1 minute and roughly 38-second burn.
Very important burn here to get GOES-T on its way into proper trajectory. And after we shut down from this burn, Daryl, we'll have about a 3-minute coast before we see separation.
You can see our altitude is 32,000 kilometers above the Earth. We're listening for that call, and there it is.
3.
And there you see it, the animation indicating the RL-10C-1 has lit, pumping out 22,890 pounds of thrust.
Closed loop control.
So there we hear everything's working good so far, that the propellant utilization system is in a closed loop control, controlling Centaur.
Performance parameters look good for this burn.
Everything's looking good as Rob Kesselman is letting us know from the flight telemetry data that the Centaur is performing well.
Controlling the mass air to near 0.
32.
Just about 1 minute remaining in the third burn.
We're currently about 32,000 kilometers directly over Indonesia.
And Daryl, there on the left screen, you see the team in the Mission Director Center, ULA, NASA, and our spacecraft customer for GOES-T watching on for this third burn, as this is the important part of the mission as we get ready to separate.
Along the bottom row, we've got the NASA and ULA
Vehicle body
team.
rates look good at this time.
Yeah, bottom row there is the NASA launch manager, Tim Dunn, and his backup, Omar Baez, along with NASA LSP, Chuck
15
Duvall.
seconds remaining in the burn.
And our program manager, Amanda Mickiewicz, there. And across the backside next to Tim is Launch Director Tom Heater, Lou Mangieri, and Chief Engineer Marty Malinowski from United Launch Alliance.
And we have MECO 3. Reaction control system is now settling at 100%.
And that was main engine cutoff number 3.
We have about 160 seconds remaining until spacecraft separation.
So the third burn, the third and final burn is complete. And now we are awaiting the biggest moment of all, the separation of the GOES-T spacecraft from the Centaur upper stage. So we got a few minutes here before that moment. That burn, it has got it close to the orbit, but not exactly.
Executing a turn to the spacecraft separation attitude.
Explain that, Mick.
So yeah, we put it near geostationary where we want to be, and as we mentioned earlier in the show, the GOES-T NOAA team will work over the next 10 to 11 days to
2 minutes till spacecraft separation.
To put GOES-T into the proper orbit at that 22,236 miles they need to be. So we'll definitely be looking at the data, but so far it looks like Atlas and Centaur has performed magnificently today in putting GOES-T where it needs to be. As you can see, Centaur, the thrusters there still moving Centaur around and stabling things out, as Rob Kesselman had mentioned, and getting ready for spacecraft separation.
Just about 60 seconds away from that separation. And there'll be video of this separation.
Vehicle attitude rates are now stabilizing for spacecraft separation. We have just about 60 seconds until spacecraft separation.
We won't have the video live, but we will get the downlink about 15 minutes after separation. So look for that on social media, NASA, ULA. Look on their social media accounts. Again, on the right-hand side is the animation that is connected to real-time telemetry of the spacecraft in relation to where it is around
30 seconds till spacecraft set. Attitude rates in all axes have stabilized at 0.
Some very intense looks.
10 seconds remaining.
For the folks on the left.
And we have indication of successful spacecraft separation of the GOES-T spacecraft.
This is a great moment right there, Daryl, as we see the team celebrating that spacecraft separation. 3 hours we've been waiting for this, and successful deployment of the GOES-T satellite.
Yeah, well, you got some hugs down there. Omar Baez and Chuck Duvall, longtime LSP manager, who's retiring in a few months. And the spacecraft team as well, up across the upper row. Handshakes and congratulations all the way around. This is the culmination of years of work that started in earnest more than 6 years ago. LSP coming in and bringing the spacecraft and launch provider together roughly 2 years ago. And now you see this is the completion of that and the mission.
And this is what it's all about. This is what we do every day and live for this. This is a great moment to deliver spacecraft on orbit for our spacecraft customer. I know Candace Carlisle and the team are excited that GOES-T is on its way, and very happy to see that the Atlas Centaur performed very well today as usual. As you mentioned, Daryl, we will get spacecraft SEP video about 15 minutes after the separation that just occurred. The team will do a quick look here in about 20 minutes of the Centaur data to make sure everything that we saw looked really good. And as part of that quick look, hopefully we'll get to see some of that spacecraft data. But for the folks watching us, as you said, look for that on the social media sites for United Launch Alliance, NASA LSP, NASA, and NOAA.
Very good. And what's it like, for these folks who are celebrating right now?
Oh, they're very, I hate to use the term again, but they're very excited. It's as you said, it was a tense moment coming up to that point, but now that we have separation and things are working well, the spacecraft team will be monitoring here, because in a few more minutes they will get indication of solar array deployment, and they're excited to be on this way, because this is the start of a journey for them, as we've been talking all night with Kevin and Megan.
With the successful separation of the GOES-T spacecraft, the Centaur will now perform its standard propellant blowdown sequence in order to inert the vehicle and complete today's flight. This will complete today's commentary of the GOES-T launch. This is Atlas Flight Commentary signing off.
So there we heard Rob Kesselman is done for the day, but Centaur will perform its last maneuver and get all the propellant out of the tank, and what he means by that is that MECO 3 was a actual guidance shutdown, so we didn't run out of propellant. We had enough propellant to perform the mission, and the guidance on board actually shut the engine down at the exact time we needed to put GOES-T where it needed to be in space. So everything so far on the data looks really good, but as I was saying, the quick look team will get together and they will look at that data, and then we will perform post-flight later in the next couple days. But based on everything you and I have seen today, Atlas Centaur did very good job for GOES-T.
Look good all the way around. Yep. And we appreciate you being here. Thank you, Mick. Great to have you alongside for another great and successful launch by the Launch Services Program.
Appreciate it, Daryl. It's always a pleasure to be here with you guys and share on these launches. And, of course, this one with you, longest one we've been together, 3.5 hour coast, my friend. Thank you very much.
Thank you, sir. We survived it. All right, we'll send it back to Megan and Kevin.
Thank you, guys. All right, so Kevin, GOES-T has successfully separated. You and I clapped along with the launch team here. How do you feel?
Mick hit it on the head. The whole team is happy.
Yeah.
Pam Sullivan, Candace Carlisle, myself. I mean, the entire program's excited. It's like the delivery of a baby. We're overjoyed.
Yeah, this is obviously a big accomplishment, but there's more to be done. What's next in this mission?
Yeah. So the next point we've talked about in the past, which is we're now going to coast out for the next 11 days to the actual operational orbit, and from there we'll be checking out the instruments to make sure that the instrumentation on board is getting the information is getting down to the ground site like it's supposed to, at which point in time then we go through the product validations. We just make sure that the products are correct. At that point, then it becomes operational, and unfortunately a little bit of time. It'll be 2023, early 2023, when we actually can go fully operational. But until then, we'll have some images to share.
Right. And again, 6 advanced instruments on board. You know, we talked about how they're going to help us forecast our day-to-day weather, but also detect and monitor severe storms. But also, this is a great tool for climate change, tracking climate change.
Absolutely. Just by the nature of the orbit. With a geosynchronous orbit, being able to constantly stare at one particular location the entire time, we're going to be able to see changes underneath, whether it's going to be associated with over land or over the ocean. We'll be able to see those changes over time and document that, and now with the highest fidelity possible.
Mm-hmm. And we know that this is weather that's affecting the Earth, but also GOES-T can monitor space weather. Can you explain what space weather is? Because it's really something that we should actually be very cognizant of. It does affect us here.
Absolutely, it really does. We become a more digitally dependent culture, and as a result, that dependence is on digital content, whether it comes from space, specifically like GPS. So with that, you can always see that for us, space weather is a player every single day.
Great. Kevin, thank you so much. And today's mission, as we know, was managed by NASA's Launch Services Program. The team considers that spacecraft separation mission success. Daryl is back now with NASA Launch Director Tim Dunn.
Indeed, Megan, and thank you. Tim Dunn is here, and successful mission. So first of all, congratulations to you and the entire launch team. This was a long one.
Yes.
So I imagine that builds up some anticipation over a long period of time.
Absolutely, absolutely. Wow. Let me take a breath here. So hopefully you guys got to watch a little bit of that excitement in the MDC and in all of our control rooms. So that is what it's all about. When we get to that spacecraft separation, it's years of work go into that one event. And now we can hand that spacecraft over to NOAA and our customer, and we're going to have reliable weather data for 15 years at least for this asset. So what a countdown today. I mean, we don't get many countdowns like this, but today we were blessed with a smooth countdown.
Yeah.
And you probably saw about the last half hour or so of that. It was like we were very fortunate. Weather cooperated.
Had weather issues in the morning, but then it really just cleared and opened up in the evening.
It was beautiful. We were having a little bit of challenge with some ground winds, projected going to be right close to our liftoff constraints. But I tell you, about an hour before T0, those started to dissipate and really trended favorably and were not even an issue. No range issues. So I commend Space Launch Delta 45 and Space Force for having just an absolutely pristine range. All the instrumentation was rock solid today, so thank you so much to our Space Force colleagues for that. For the launch team, when you bring a combined government and contractor team together that is performing at this high level, it's just it's so good for someone in my position to be able to sit back and watch this orchestration of all this talent. So I really appreciate the women and men of Launch Services Program, my program. They're just amazing. I love you guys. Thank you for everything you do to get us to this point. We get to work alongside incredible folks from United Launch Alliance that build this mighty Atlas. Just what an incredible launch capability this vehicle is. And then we bring our customer in this case NOAA and Goddard Space Flight Center, that have brought this incredible treasure, this precious weather capability that's going to benefit our nation for a decade and a half. And to put it all together, have a successful countdown, smooth countdown, a perfect launch, put it on orbit, Just a great feeling, Daryl.
Extremely well done by all involved. And now over the next 11 days, the team at NOAA will refine that orbit to get it in exactly that geostationary position. And then GOES-T will be GOES 18, and we'll start operations. You know, as you talked about the team and all the hard work that's being done, it doesn't end here. You guys have quite the manifest going ahead of the year. Talk a little bit about that.
It's a very exciting year. So these are our big missions. So we have 3 more big missions for the remainder of calendar year 2022. We're going to go to a metal asteroid with the Psyche mission in August on a Falcon Heavy. Really looking forward to that. That one's going to depart Earth from here on the East Coast at the Cape.
That'll be a fun one.
Then we're going to transition to the West Coast and go out to Vandenberg for a couple of missions. We go with our NOAA customer again, and we do the other version of our national weather capability, the polar orbiting satellites. That's going to be JPSS-2 at the end of September from Vandenberg on an Atlas V. So we get to work with ULA once more and this incredible team. And then we're going to finish out the year with a surface water surveillance capability that is an international collaboration with the Europeans called SWAT. And we're going to launch that on a Falcon 9 from Vandenberg. And then mixed in amongst this, we're going to do our advisory work. We're going to work alongside some of the smaller, newer providers. We have a mission called Tropics on Astra. So we got 3 separate launches from the East Coast, spaced out probably over the period of a couple of months. So that's going to be very exciting. And then we're going to have a lunar mission this year. It's small but mighty. It's called Capstone. And we're launching that on an Electron rocket from Rocket Lab from New Zealand. So a lot of excitement. We're very excited about the prospects that lie ahead of us. We're really excited about what happened here today.
Absolutely.
But always have our eyes ahead to what's coming down the road.
Great job, Tim Dunn, NASA Launch Manager for Launch Services Program. Thank you. Great job to your team. Appreciate you being here and giving us some comments.
You're welcome, Daryl. Thank you so much.
All right. Megan, we'll send it back to you.
Tim, congratulations, and thank you, Daryl, and to Mick as well for all the commentary today. That'll do it for us here at Kennedy Space Center for this live coverage of NOAA's GOES-T. A big thank you to everyone who participated, especially you, Kevin. Thank you so much.
Thanks for having me. I appreciate it. Oh, yeah. Oh, yeah.
It'll now take 11 days for GOES-T to get to its geostationary orbit, about 22,000 miles above the Earth's surface. At that point, it will be renamed GOES 18. NOAA will test GOES 18 to make sure everything works, and if all goes well, they expect to put it into service as GOES West in early 2023. You can continue to follow this mission. I'm sure Kevin would love that by scanning this QR code that you see on the bottom of your screen there. You can also just go to the website if you can't scan the code right now. So that website is noaa.gov/GOES-T-launch. Again, noaa.gov/GOES-T-launch. Thanks again for watching. Have a great evening, everyone.